Hello, so let me hope everybody is fine. Once again, today we are back with our chemistry. So today in this video we are going to look at section A, items, and the topic we are going to be covering is formulae and stoichiometry. Therefore, watch this video to the end, because at the end I've put a practice item for you. So now let's dive in and we see the type of the items that we are having. Okay, so this is our item, and then before we start answering, let me give you a piece of advice that you should always use. It is like a cheat code that you should have to use to make sure that you pass these items actually in all examinations. 1, always read the scenarios more than once. The reason as to why you have to do that is to ensure that you understand every bit of the scenario. So for here, we are going to read for the first time, and again we shall have to go for the second time. And then when reading for the first time, don't only read this part of the scenario. Make sure that you come and read also these parts, all of them, A, B, C, D, even if it goes up to Z. First read all of them before you come back to read for the second time. If you fail to understand in the second time, then go on and read the third time. So for our chemistry paper, the standard one, the duration is 2 hours, and that time is enough. Therefore, each item, give it enough time. Why? You are attempting only and only 4 items, and these items are not demanding. What they need is critical thinking. If you think critically, then you will also have to give answers that are straight to the point. So now let's go through the item and see. We are reading for the first time. Let's read together. A group of students were faced with a unique solid substance X, which they suspected to be an element. 0.3 grams of the element could burn in oxygen to form 0.5 grams of the solid product. One of them picked interest in what could be the chemical formula of the product. However, he did not know how to determine the formula. When they contacted the laboratory technician, he gave them the atomic number and atomic mass of X as 12 and 24 respectively, and the symbolic representation of oxygen as 16.8. Task: as a student of chemistry, help the learners to A. Understand the nature of substance X. Determine the formula of X. So this is not the formula of X, this was a typing error. They are saying they want us to determine the formula of the solid product. Know the environment consequences of the element. So now this is the first reading. Let's go and read the second time, but then in this second time we shall be analyzing every bit of it. Now we are already familiar. The first reading makes you familiar with the words that are used in that if you find a new word, you will try to feed it and then get to read it as it is used in the scenario. But then when you come to the second reading, you shall always have to understand, read a statement and get to know what it means. So the best thing always in this second reading, make sure you read every statement, translate it back to your local language, get to know what does it mean. Remember, when you understand the scenarios, you shall always take very short time to give the responses. Take it like if they ask what is your name, you easily give that answer that my name is this. Why? You already know what that statement means. But if someone using another language comes in and asks you what is your name, but using another language, you first look at them and you won't give any response. Why? You don't know what they are saying or what they are telling you. So also here, read the statements, translate them back to your local languages to make sure that you understand very well. We understand well in our local languages. I hope we all know that. Now let's go for the second reading. They are saying a group of students were faced with a unique solid substance X, a unique solid substance X, which they suspected to be an element. So the students suspect X to be an element. Then 0.3 grams of the element, and remember we say the element is X just from this way. So 0.3 grams of X could burn in oxygen to form, so could burn in oxygen to form 0.5 grams of the solid product. Therefore, if it burns in oxygen, then what it will be forming, remember the element is X, burning in oxygen, it will be forming an oxide of X, because all elements, when they burn in oxygen, they form their respective oxides. I hope you can recall that in your reactivity series. For example, if we have magnesium burning in oxygen, we shall have magnesium oxide. If we have oxygen burning if we have carbon burning in oxygen, we shall have carbon dioxide. So they form oxides. Therefore, our solid product here is a X oxide. So one of them picked interest in what could be the chemical formula. So they want to know the chemical formula. The chemical formula is not this, even though we don't know what X is. It was kept as an unknown, and therefore, by the way, before even we continue, if they have not specified the element, unless if they tell you specify or identify, you should always never and never talk about its name. Just call it X, even though you get to know that maybe X is calcium, X is sodium. Don't talk about sodium anyway, even if you've gotten to know that. Just continue calling it X until they tell you that now what is the name of X. So now they want the chemical formula of this X. Then, however, he did not know how to determine the formula. When they contacted the laboratory technician, he gave them the atomic number. The laboratory technician gave them the atomic number and the mass number of X as 12 and 24. So respectively. So respectively meaning this 12 is the atomic number here. So atomic number is this 12. So respectively. Why? 12 is the first to appear. Also atomic number here is the first to appear. So respectively means in that same order. So we have A there, and then this one is the mass number. So also 24 is the second to appear as the mass number here. Therefore 24 is the mass number of X, and the symbolic representation of oxygen. So when you look at this symbolic representation, you always had a representation. Let me give, like if I have this for all elements, you can go to the periodic table and check. If an element is written like that, like we see oxygen, we shall always have its mass number written at the top. So its mass number is always written at the top, and then the atomic mass or the atomic number is written at the bottom. So here 8 is the atomic number, while 16 is the mass number. So now we are done with interpreting our scenario. So now they are saying, as a student of chemistry, help the learners to understand the nature of the substance X. So before even we start attempting identifying the nature of elements, it's like getting to know the behavior of the elements. If you want to know the behavior of elements, go back to your periodic table and you know what makes the elements unique and what differentiates these elements. And the difference between the elements always is the number of electrons that they are having. It is always the number of electrons that they are having. So now let's see. Here we are going to have our response. Like I was telling you that always what makes the elements different is just one, and what makes an individual element unique, different from the other, it is just one thing, that is the number of electrons. So the number of electrons an element is having, it has them solely. In other words, it is the only element having those particular electrons. And remember also that the number of electrons always corresponds to the number of protons, whereby the number of protons, it is equivalent to the mass number of that is equivalent to the atomic number of that particular element. So when we come back here, they told us that the atomic number of X is 12. So they want us to give the nature of X. So we shall base on that to give its nature. Firstly, I will start with writing the electronic configuration of X. When I write the configuration of X, it is 2 to 8 to 2. That is 8 plus 2, 10 plus 2. Those are the 12 electrons. And when I look at the number of electrons in the outermost shell, from here I can get to know the group. Remember, we don't know what X is, but getting to know how X is, we have written the configuration, and the configuration gives us this following information in the periodic table. The configuration can tell you the period to which a particular element belongs. The configuration can still give you the group to which that particular element belongs. And then when we look here, the configuration tells us that this element is in period 3. Still, it tells us that this element belongs to group 2. Then after knowing that, you have cracked the code, and then you can ask yourself, what is the nature of group 2 elements? So you have to know that. Now we have said here that since X has 2 electrons in the outermost shell or energy level, X is a group 2 element. That is in the periodic table, all group 2 elements have 2 electrons in the outermost shell. Now I come to giving the category. We have very many answers in which you can give the group of this, and also still in your first 20 elements, you know them 1 to 20. After looking at the 12 electrons, you can easily know which element X is. But like I said, don't talk about the name of X unless you have been told to do so. Don't identify X that now I've seen X is having 80 electrons, therefore X is oxygen. Maybe I have seen that X is having 1 electron, maybe X is hydrogen. You don't have to identify unless you have been told to do so. But now part A was asking for the nature of the element X, and for the nature they are asking for the category, the class of group of the element X. So there are very many ways we can give the nature. How does X behave? Since it belongs to group 2, we all know that group 2 elements are called alkaline earth metals. So group 2 elements, we call them alkaline earth metals. It is those that of group 1 that we call alkali metal, and the difference is here. Group 1, they are called alkali just because they form strong, very strong, actually you can add the word strong, very strong alkaline solutions. Also, when you come to group 2, they form alkaline solution. That is when they react with water, or if they react with the oxygen and the oxide is dissolved in water. You see that the alkaline solutions of group 2, they are not that very strong compared to those of group 1. That's how they have that small difference. Therefore, we are saying that X is an alkali earthy metal. Since it reacts with water, so X can react with water, forming a relatively, so I've used the word relatively strong alkaline solutions. I've used the word relatively strong just because we have group 1. For group 1, they form alkaline solutions that are very strong. So, and I've tried to give an example. Remember here we said you have to give the category. Since here we are dealing now with the element, you have to give the category of the element. You have give the reason as to why you have to give the reason as to why you have given this category, and lastly you must give an example. That is, if you want to get all the scores on this number or this item. Now we can still have another way of giving the nature. So we have given one, that X is an alkali earthy metal. So basing on the word alkali, that's why we have said it reacts with water, forming alkaline solutions. Or another person can say X is a group 2 metal. Now we are classifying it as a metal of group 2. The reason is it loses 2 electrons when forming a compound. For example, forming a compound with oxygen. Let's say we give an example here, it is calcium. So calcium will form calcium oxide like X. So also calcium has 2 electrons in the outermost shell. So when it is reacting, since it is a metal, it will be forming an ionic bond with this compound, whereby it will have to give away these 2 electrons in the outermost shell. So we can also give that X is a group 2 metal because it loses 2 electrons when forming compounds. Or you could say that X is a metal after knowing that it belongs to group 2. All elements in group 2, they are referred to as metals. Therefore, X is a metal since it forms an ion by losing electrons like sodium. So all metals form ions by losing electrons. So that is with this part of nature. So we have given all these alternatives, but while answering you have to give only one. You might not even include this iconic configuration. This is just for your own working, and then you choose on any of these ones. Let's go on to the next part. So now when we come to the next part, it is saying determine the formula of X. They want us to calculate for the formula of X. Now we on part B, calculating for the formula of X. They want us to get the chemical formula of X. The chemical formula of X. Remember, they said that one of the students picked interest in what could be the chemical formula of the product. Therefore, we want to get the chemical formula of the product. Now this is, we shall have to get the empirical formula of this product. So now let's go and we see how we can calculate for this. Now for the formula of oxide, remember in the scenario they gave us the mass of the solid product, and we say the solid product is the oxide. In this case they said the solid product is 0.3 grams, and also they gave us the mass of the element X, but they never gave us the mass of oxygen. That's why here you can see that I got to get the mass of oxygen. I have 0.5 subtracting 0.3, subtracting 0.3, and here we get 0.2 grams. That is the mass of oxygen. Now we shall have to use a table to simplify this. When you look, our first thing, we shall write the elements, and the elements in the solid product, it is X, and then the oxygen. The next step shall be writing the mass. When you use the table, it makes the work very clear. So here we are calculating for the empirical formula, although the question the student was wanted to know the chemical formula. The chemical formula we have the molecular formula, and we can have the empirical formula. But getting the empirical formula, you must have the relative formula mass or the relative molecular mass, but we are not given the relative formula mass. Therefore we could only calculate for the empirical formula. Therefore here we are, like we said, start with elements, list them. Always use a table. It shall always make your work very clear. Next, we shall have to write the mass of the elements. X is 0.3, while oxygen is 0.5. Sorry, oxygen here was 0.2, not 0.5. 0.5 was for the solid product, so X is 0.2. Then the next step is to calculate for the number of moles in these masses. So getting the number of moles, we shall get the mass of the element divided by the mass for 1 mole of that particular element. So the mass of X for 1 mole of X is 24. It was given to us as the mass number. Therefore we shall have 0.3 grams of X that reacted divided by the mass for 1 mole of X, which is 24. Similarly, the mass of oxygen is 0.2, and then we shall have the next thing. After dividing, we have 0.125. that is, when you divide 0.3 by 24, you get 0.125, and when you divide 0.2 by the relative the mass number of oxygen, which is 16, it was also given to us in the other representation. You already described that. We get 0.0125. Then after getting the number of moles, therefore these are the number of moles of X in the 0.3 grams of X that reacted. Also the 0.2 grams of X that reacted contained 0.0125 moles. Therefore, for us to get the mole ratio, we shall have to identify the smallest number of moles, and the smallest number of moles, it is 0.0125. This one is 0.1. there is no 0. Therefore this one is very small because it has to first increase up to 9, then it turns to 0.1. Therefore 0.0125 is the smallest in that case. So for you to get the mole ratio, you shall get the number of moles that you have got in this step divided by the smallest. So number of moles divided by the smallest. So the smallest is 0.0125, and therefore when we divide here, we get 1. When we divide this one here, we also get 1. That is the mole ratio, and that's why I've included this. So don't forget that, to show that this is a mole ratio. So it is 1 to 1. That means the number of moles in the formula X, there is 1 mole, and for oxygen there is also 1 mole. That's why I come up with this x0. If maybe let's say this was 2, how to say number of moles of x here, they are 2. Let's say they were 2. I'd write x2 as a subscript. Then I write the oxygen. I don't include 1 because it is already 1. So that is that with getting the formula. I said we shall stop on that. This one we call it the empirical formula because they never gave us the relative formula mass of the solid product. We would go further and calculate for the molecular formula, but this one is what we call the empirical formula, and we have to stop on that one. Therefore, let's go to the next part. Let's go to the next part, and we see. So part C was saying, as a student of chemistry, help the learners to know the environmental consequences of the element. So what we should know, they want us to give the side effects here. It is for the case, it is what they were meaning in this, the side effects of the element. And how will you give the side effects? You will give the side effects after knowing what X is. But like we said, don't again talk about its name because they have not asked for its name. But in your mind, as a student who covered the first 20 elements in your periodic table, and you know the ways of identifying the different elements, you know that X is such and such an element. Therefore, X with that basing on the atomic number that they gave us, basing on the atomic number of 12. They said X has an atomic mass of 12. So this one, the 12, we said is the number, or we can refer to it as the atomic mass. And atomic mass is the same as the number of protons, or what we call the proton number. On top of that, you can reflect and get to know that the proton number is always equal to the number of electrons. And then still further, you get to know that the number of electrons do define what a particular element is. Therefore, 12 being 12 electrons, the element having 12 electrons is magnesium. Therefore, we have got to know what this is. It is magnesium. So from there, we have known that it is magnesium. They want us to give the side effects of magnesium to the environment. But again, remember that whenever you give a side effect, you should also follow it with a solution. But like I said, you've used this to identify that the element is magnesium. But when giving your solutions, don't write or don't talk about magnesium. Why? This question is clear that gave the environmental consequences of X. So why do you talk about magnesium yet they talked about X? Knowing magnesium, just keep it at your heart. Why? It is the one that is going to help you give these environmental consequences. Where you would mention magnesium, just mention X, that magnesium does this, give X, 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 unless if they had told you. Okay, so one, we have known that is magnesium. The first answer is X contributes to water hardness. So we all know this, that the ions responsible for hardness of water, it is magnesium and calcium. Those are the major ions. Therefore, in water, magnesium ions contribute to hardness, and we are saying water hardness can scale the pipes, the clogging of the pipes, wastes soap. We already know this, it wastes soap, and still it increases energy usage in water heaters. Even if there are other kettles at home, if they have these boiler scales, the amount of firewood, the amount of charcoal that you use increases if the boiler scales do increase. Therefore it wastes the energy, the fuel that is used. And then remember, we said when you give the side effects like I've given here, you can decide to give one that contributes to water hardness, that leads to wastage of soap, that is during the washing of clothes, increasing energy usage, that is during the cooking processes. They are scaling pipes. Remember, there are some companies whereby they do use some pipes, metallic pipes, for distributing or serving tea into different offices, or even water. So if there is these ions contributing to hardness, it can cause those scalings on those pipes, whereby they can end up even getting blocked. So remember, we also said that whenever you give a side effect, you should follow it with a solution. That's why here I'm saying this can be solved by treating the water with lime. That is one way of breaking water hardness. It is a chemical method. You can treat the water with the lime. Lime is calcium oxide. Then you can also treat the water with sodium carbonate. Still, it can remove the hardness. You can distill the water. You can boil the water. So you talk about ion exchange. You talk about different methods of breaking water hardness, either temporary or permanent. But we just talk about one. For me, I've just given different examples. You can just talk about using lime, another on sodium carbonate, another on distillation, another on boiling, another on ion exchange, and so on. So we have another side effect, and the other side effect, we are saying high amounts of X in water bodies. That is, if there is high deposit of X in water bodies, that is high deposits of magnesium ions in waters from industrial discharge. When these industries do pour their waste, liquid waste, into water bodies, it can harm aquatic animals like fish. It can harm aquatic animals like fish, and still this can be mitigated. I'm following it with a solution by treating the wastewater to remove ions of X. So if the ions of X are removed, then also the water can be maybe somehow safe to those aquatic animals. Lastly, the last side effect with the solution that I can give here is that that excessive use of the magnesium of the X, of fertilizers containing X, excessive use of fertilizers containing X will increases alkalinity. Yes, excessive use of fertilizers containing X increases soil alkalinity, affecting nutrient availability. This can be solved by using organic fertilizer or limiting the use of fertilizers containing X as the major nutrient. So when we overuse fertilizers containing magnesium, remember we said it is an alkaline substance or an alkaline earth metal. Therefore, whenever it gets into combination with water, the solution formed is an alkaline solution, and therefore if there are very many, it means that soil shall be highly alkaline. So that one will affect the mineral availability in the soil, and still it poses, since there is a high concentration of the magnesium ions in one area, it also poses a competition for absorption of other ions like potassium, sodium, calcium, which are also needed by plants. Therefore, the way of solving that is you can use organic fertilizer. But if you want to use the more specific fertilizers, the synthetic, what you should do is to limit the amount, or even you can make regular soil checkups to check on the pH. That is, if you overuse them, you can always check on the pH of the soil. So that is that with this. Now here I shall leave the scenario item that I said. So I shall leave I shall leave for you the scenario item for practice. And there is the scenario for practice. So do it. We shall have its corrections in the next video, and then you shall have to compare and see whether we are moving together. I just wish you all the best, but with chemistry, endeavor to practice. With practice, you shall become perfect, and you shall always be a chemistry genius. Get to know that these scenarios are very simple to attempt. Don't forget to subscribe, share this video to all your other friends, and then we shall have to learn together. If you have any topic that challenges you and you would need any example, you can do comment it in there in this comment section, and then we shall have an example from that topic in our next video.